All right, in this video we're going to cover the leap year question. This is a classic. I remember doing it when I was in school with a different programming language, but the part that makes it tricky is not the programming. The part that makes it tricky is the rule, which existed before computers. So the deal is we're going to get a year, and we're going to ask whether or not it's a leap year. The sun goes around the Earth, no, the other way, in 365 days, but not exactly. So if you have a calendar of 365, it gets off a little bit more every year, and by the end of your life, it'll be totally different. You might be born when July is summer, and then you'll die when July is winter. And people in the past, the Romans, for example, kept adjusting their calendars because it was never quite right. So people decided it's about 365 and a quarter, so what if we add a day every 4? That helps, but it's not quite the full story, and they had to make one more adjustment, which we'll see. So let's give it a shot with the absolute basics, and then add a little more, and then add a little more. So I'm going to say, is it divisible by 4? That's the first thing we check, and that gets us most of the answer, except for the exceptions. So I just made a variable called div4 because I didn't feel like typing the whole divisible. And we get that by using this percent operator, which is the year modulo 4. This is a division, and then it tells you how much is left over. It's used for things on cycles, like a clock. If you take 13, well, that's the same as 1 because it's on a cycle of 12. So if we say if div4 print, that's a leap year. If I could type. And then we say otherwise, that's not a leap year. And that does get us the right answer most of the time. It's not the whole story, but for example, if I said 2000, well, that was a leap year, and they'd correctly tell us. If I say 2001, well, that was not, and they correctly tell us. However, like I said, there are exceptions. Even if you add the quarter in there, you're a little bit off, and after a century or two, the calendar doesn't line up anymore. So people decided, okay, every 100, we're going to take it off. So, like for example, 1900. It says it's a leap year now, but it shouldn't. It shouldn't be. 1900 did not have a leap day. So the exception is, well, if it's divisible by 100, that's different. So we use the same modulo 100. Equals 0 means there's nothing left over. So I'm going to say, and not div 100. The way in casual speech we say and not is unless. Okay, unless doesn't exist in Python, but and not is a pretty good approximation of what we mean. So now it's going to get some of those right that it shouldn't, or that it didn't before. So for example, 1900 correctly is identified as a non-leap. 1904 correctly is identified as a leap, but it's still wrong a little bit because here's what happens. 2000 should be a leap year. 2000 was a leap year, and that's because there's an exception to the exception. Every 4 centuries goes back to a yes. So I'm going to say div 400. And this is what happens when you write code. The code is not the problem. The code is fine, and you can write a few if statements. The problem is the stuff outside the code, the rules that come from calendars, businesses, customer requests, government regulations, all kinds of things where people say, hey, nice code you got there. What if we add more complication to it? And when you express that complication in code, it appears to be complicated itself. But that's just because of the world not because of Python or Java or whatever language you're using. So how do we do that? Well, we have to say, if this and not this, there's one more operator we haven't covered yet, or this. We used and, not, and or. That's all three of our primary logical operators. So let's do 1600 should be a yes. It is. 1700 should be a no. It is. 2023, our current year, should be a no. And it is. So this is a classic problem that people always use to learn conditionals because it covers the and, the or, and the not once each. It's also classic because it's just an example of the thing I was talking about, where you write code and then you have an exception and then you have an exception to the exception. That pattern, by the way, no matter what you're talking about, if you ever have an exception and then a tiny sub exception, it's always and, not, or. So you can remember that pattern and use it for other things that are not just leap year. There you go. That's how it works.